is looking at 325, 326. It's finding experimental probabilities. You're studying this example. It's showing you an example, okay? It's telling you when she's drawing a colored cube, she records the colors. And it shows her results. You can see she drew from the bag. She got 3, then 4, then 5. So she's drawing 12 times. So that helps to give you the denominator for any of your probabilities. So moving on. Why is the denominator of each ratio 12? That is the total number of draws. Okay, whenever you start seeing numbers, you're going to get like me where it's like you see them and you're like, okay, I need to automatically add these up. I need to figure out what the denominator is. Okay, so I'm already looking over here. I'm already going to add them up. 10, 11, 12. So my bottom is always going to say 12. 12, 12, 12. Okay. He repeats her experiment with different results. What is the experimental probability? Experimental probability means you actually do the experiment. There's also something that is not experimental probability. That is just the theoretical probability, which is like if you were to do it, but you're not actually doing the experiment. So I love that they're saying experimental probability already. You need to remember the difference between that and theoretical. Okay. So this one, experimental probability, red, his results were 2. So I put a 2 over it. Yellow was 3. And blue was 7. So that's the experimental probability for each, right? 2 over 12, 3 over 12, 7 over 12. Some people are overachievers. They're going to reduce this. This is 1/6, and this is 1/4. This one cannot reduce, so we'll keep it 7/12. All right, looking at the results, which color is there more of in the bag? Red, yellow, or blue? How do you know? Well, the highest one for him was blue, and the highest one for her was blue. So blue has the most colored cubes because Nadine and Philippe both drew them the most. Okay, all right, going on the back. Spinner gets divided into equal sections. They're numbered 1 through 5. Leo spins, and here's his line plot. How many times did he spin the spinner? They're just asking us to add all this up. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So how many times do you spin the spinner? 20 times. I'm already making that my denominator over here. I don't want to forget. 20, 20, 20, 20. Now, finding each probability. The important thing that we remember when you're on a state test or any test is that when they say find the probability, it's one of the only times they're talking about fraction, fraction, fraction. They're not asking you the percent. They're asking you to write a fraction. So I know that they're telling me fraction, write a fraction. So what I'm going to do is follow what they said. So I've got 2 1s, so 2 over 20, 3 2s. Looking at 3, 1, 2, 3, 4, 5 3s. Looking at the 4s, 1, 2, 3, 4 4s. And we're talking about 5s. We've got 1, 2, 3, 4, 5, 6. You know you're right if this adds up to being 20. So 5, 10, 14, 20. So we got 20 20ths when we add them all together. Okay. Celia uses the same spinner Leon used. In problem 4, she spins 24 times. Remember, he spends 20. She spins 24. Okay. What is the probability the spinner lands on 5? Well, we have to get to 24, so let's count our tallies. And then whatever's left is going to go here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, 15, 20. But remember, she spun 24 times. So if it's at 20 now, we got to add 4. Okay. So the probability the spinner lands on 5 is 4 out of 24. This is because there's 20 out of 24 for the other numbers, leaving 4 missing. So 4 must be the probability of 5. 4 out of 24. Combine Leon and Celia's response to find out the probability of spinning on F4. Okay, well, when we look at Leon, whereas he is all the way up here, the probability of him getting a 4, combine their results for getting a 4. So here's his 4, here's her 4. They're asking for 2 different questions, which can get confusing. I will always use a highlighter for those kind of questions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so the probability of getting a 4 was 10. The hard part is that you have to also add the 24 and the 20, because that's a denominator. So if I've got 4 plus 6 equal 10, I also have to add 20 plus 24, which equals 44. So the probability is going to be 10 over 44. If I want to reduce, I can also cut it in half and be 5/22. Okay. Use the results of problem 5 and 6. Find the sum of all the probabilities for both experiments. Compare the sums and explain your results. Well, I kind of spoiled this for you when I explained that you need to get to 20 over 20 to double check yourself. If you add everything, if you add 2 20ths plus 3 20ths plus 5 20ths plus 4 20ths plus 6 20ths, you're going to get 20 over 20 or 1. That makes sense, right? Because you're always spinning, so you're always going to get, if you spun 20 times, these are going to split into different numbers, but they're going to add up to 20 again. This one right here, it's talking about the 24s. So now you have to add up all of these. So she got 4 plus 3 plus 7 plus 6 plus 4, and that's 7, 14, 24. 24 over 24 or 1. Okay, compare the sums and explain your result. They both add up to 1. This always happens with probabilities. All right, so you got that. That is going to be 325 to 326.